Hi, Vincent here with a very much long overdue YouTube video in general, but today we'll be doing a Libre video. As per requested by one of my subscribers, they wanted me to show them how I would design or model out Tool Toby's tabbed bushing sleeve in Alibre. So that's what we'll do today. So let's get started. The project's already set in millimeters and in grams, so I'm just going to start. So the first thing we're going to do is, starting with on the ZX plane, we're going to build up that main cylinder shape. So I'm going to create a sketch on the ZX plane, and using the circle tool, I'm going to create the first circle, which is the through hole of 50 millimeters in diameter, and then using the circle tool, second one, we're going to enter in 75, and then we can deactivate the sketch. Now that we have this sketch, we can now just extrude, and it says from the drawing that the height of the cylinder is 60, so I'm going to enter in 60, click OK. The next thing we're going to do is create a sketch on this XY plane, and that will allow us to build the tab. So creating a sketch, XY plane, and the first thing we're going to do in this sketch is we're going to project in the cylinder for reference. So select this face, create reference figure, maintain association. Now, there are a couple things to note, or three things in the diagram to define this tab. The first thing is that from end to end, the tips of these tabs, there's a 90 millimeter distance between the tips. The second thing is that the top of the tab, there's a 16 millimeter offset from the bottom of the cylinder. And then the third thing is the lines, the angle of the line that creates that tab is at 60 degrees. So we're going to define all those at once. So we're going to be really working with half of the model to begin with. So, so the 90-degree distance, we really just need to put in a reference or draw a reference line of 45, and then we can just mirror the tab onto the other side when we're done. So using the line tool, I'm just going to draw any kind of horizontal line, and then we're going to add 45. So this is 90 divided by 2, so 45, and this becomes a reference line. And we want the reference line to be right along the center. So I'm just going to use a vertical constraint between here and the center. Let me try that again. A vertical constraint between this point and the center. That puts it right along the center over here. And then also dimension in that 16 millimeter offset from the bottom. 16. There we go. And before we forget, we're going to also convert this line into a reference line. Next thing I'm going to do is I'm going to just kind of draw a triangle, which will be the shape of our tab. So using the line tool, I'm just going to kind of rough it in, something like this, and something like that. Okay. And the first thing is I'm going to add that 60-degree dimension. So between this line and this line, there needs to be a 60-degree angle. And then the next thing is I'm just going to make sure I want to add a vertical constraint between all these 3 points. So vertical constraint, this one and this one. So that's done. And there we go. This triangle is fully defined. I can deactivate the sketch now. And here, I guess the trickiest part is that this says that this tab kind of has circular edges. So you can think of it as like following a circular profile. To me, intuitively, that immediately means that I should probably use some kind of revolve to get that circular shape. So I'm going to use the revolve tool, and we're just going to do a 360. And the axis, and the axis is just going to be on the center over here, and that'll give us our tab. Obviously, it's not done yet, but that is really how we would do our tab. I guess the next thing we want to do is we're going to draw another sketch on the XY plane, and we're going to kind of define these slots that kind of cut all the way through. So we're going to create another sketch on the XY. Again, we're going to project in, I guess, this bottom face over here. Everything's relative to the bottom, so I'm going to project in this face. So create reference figure, maintain association. And I guess the kind of slots is comprised of two primary shapes, a rectangle and then an arc. So first thing is we're going to draw a rectangle. We're just going to draw it anywhere, and then we'll constrain it later. So first we see that the rectangle has a height of 30. So I'm going to put in 30. the width of this rectangle should be 6. So I'm going to put in 6, and that's that. I'm going to make sure that this is aligned to the bottom. So I'm going to use this collinear constraint. So I'm going to select this line and then this bottom line edge. And now that's aligned. And then the other thing is we want to have a distance from the middle. There's a distance of 7. So I'm just and then I'm going to add that dimension in that 7 millimeter distance from each other, from the center. And that gives us the rectangle. Next thing we need to do, we can either draw an arc or draw a circle. I think drawing a circle for me is the most intuitive because I can just find the center of this rectangle and then just click on this edge. And now I have that circle. Next thing to do is we can use the trim tool to trim away the piece that we don't want. Yes, trim it. And then if we trim away this line, everything becomes undefined. So the easiest way is to just kind of like select this line and then convert it into a reference figure. And deactivate the sketch. That's our slot. And now we can just cut through everything. So we can do an extrude cut. And then through all is probably fine. Click OK. I can now just mirror this onto the other side by using the mirror tool. So mirror, and we're going to mirror that extrude cut feature. The mirror plane, we're going to select this YZ plane. And now that feature is cut. Now the shape is, I guess this is mainly the hardest part, but we have the tab here, but of course we have these unwanted faces over here. So what can we use to get rid of unwanted faces? Well, Alibre has a cool feature called delete face. So let's just do that. So when we use remove face over here, I'm going to select this face I don't want, this face I don't want, and then this face and this face I don't want. So those are the I guess the 4 faces. I click apply, and there we go. That's that. Now we have our tab. So I guess the remaining features are pretty simple. We just need to do a couple of extrude cuts on the top and then this tangent winged tip thing that comes off of the base, and then we're done. Okay, so in order to do, let's work at the top first. So I'm going to create a sketch off of this top face. And I guess the easiest thing is to work with the one that's horizontal. In order to create this first slot, we're going to project in this inner circle. So project, I'm going to project this inner circle, reference, maintain association. And here we're going to draw in one more reference line because it says here from the end of this circle to the tip of that slot, there is a 58 millimeter distance. So I'm just going to draw in a reference line. Again, enter in 58, or making sure it's horizontal. I'm going to convert this to a reference line. And then also make sure it's sitting right on this line over here. So again, I can use collinear, this one, and the middle axis. So now that reference line is done. So now basically now I need to just draw in that first slot over here. And in order to do that, it's given that the height of the slot is 12 millimeters. I'm just going to draw in a vertical line. So 90 degrees, 12 millimeters. And then I want to make sure that it is vertically aligned over here. So using the vertical constraint, this point and this point. And then also I want to set this as the midpoint. So I'm going to use the midpoint constraint. I'm going to select this outer point, this inner point, and then this last middle point. And now this line is constrained. And the last thing to do, of course, is to just draw a line, draw another vertical line, and making sure that it is 180. And we want to make sure that this line sits on the circle. So I'm just going to use the coincident constraint. I'm going to click on this point and click on this circle. And that line is now defined. I'm going to just mirror this line onto the other side. So I'm going to click here, click on that line, mirror axis. I'm going to click on this line, click OK. So that's mainly done. And then now I just need to draw in that arc to finish off that tab. So using the arc tool, click on the center over here, the center of the circle, click on the first point, click on the second point, and that is done. I can deactivate the sketch now. And here we just need to do an extrude cut. And the depth of this cut, let's see. The depth of this cut is 13. So we're entering 13, and I guess I need it minus 13. Yep. And that creates that first cut. So the next thing we can do is we can just use the circular pattern. And here, we're just going to pattern one copy on one side and then mirror that copy over the XY axis to get it onto the other side. So selecting the circular pattern, I'm going to select the extrude cut that we just created. And then the instances we want here is 2. So we just want 1 right above over here. And we can just select angle, and we can select 70 degrees? No. Yeah, 70 degrees. And then the center, we can just select the center, this axis over here. So we get that first cut. Click OK. We can basically do the same thing, but do like a -70. That also works. Or we can just mirror. Up to you how we want to do it. But I'm just going to use the mirror tool. I'm going to mirror this feature pattern that we just created. The mirror plane is going to be on this XY plane. That gets that cut on the other side. So the last thing we need to do is, I guess, create that last piece that sticks out. So first I'm going to create an offset plane off of this top face, because the piece that sticks out is 10 millimeters from the top. So from this insert plane, I'm going to enter in 10. It's in the right direction. Yep, it's already in the right direction. And then click apply. And then now I can create a sketch on this plane. And here we just need to project in the most outer circle, reference figure, maintain association. And then, yeah, it's very, very simple from here. So I can create one circle that has the through hole of 18. Let's make sure that we have a horizontal constraint between the center of this circle and the center of that. What else? And then it also has a distance of 70 millimeters from center to center. So I'm going to add that in, 70. And then I'm going to create another circle. And this has a radius of 20, which means the diameter is 40. And then I need to draw a line. So from here, so somewhere over here to this, yeah, touching this outer circle, that's fine. I need to now add the tangent constraint. So this line needs to be tangent to this circle, and also the line has to be tangent to this circle. And to make things easier, I'm just going to mirror this line. So mirror the line over the mirror axis will be this center over here, and then trim away the part that we don't need. And that's pretty much it. Deactivate the sketch. Now we just need to do an extrude. And let's see. What does it say? What do we need? The width of this is 8. So I think it's 8. Let's see, which way do we extrude? This other way. Okay, so -8. Click OK. Oh, it's not happy with that. Oops, missed a step. We forgot to close off this arc, so we need to create an arc from the center over here. Click on this first point, click on the second point. Now the profile is closed off. Now we can extrude. Oh yeah, so I totally ignored this warning. And that's pretty much it. That is the part. So in order to calculate the mass, go to the material, select from library. I already have Tooltobi's materials in my materials library. Select ABS, click apply. And then to calculate the actual mass, go to inspect, physical properties, calculate. And here we get the mass of 156 grams, which is the solution. All right, that was a long one. I haven't been doing videos in a while, so this is taking me a little bit to get back into it. Hopefully this helps. Thank you for requesting this tutorial, and I hope this helps you. Thanks for watching. Have a good one.